Okay, let's reconvene. So your book gives you some equations here that I think I really need to flesh out for you. So let's take a look at that. So let's work really general here. So here's a coordinate system. X, Y, Z. We have two atoms, so we're going to look at a diatomic molecule. Call this one M1. Call this one M2. This will be R1 vector, R2 vector. This distance here will be R1 minus R2 vector. And then we'll have some center of mass here. And we're going to call that capital R for now. I'll change into the notation that your book uses, but I prefer to use this more generalized notation first. So if let's keep in mind here that the center of mass, right? The center of mass is going to be equal to M1 R1 plus M2 R2 over the sum of the masses, which means then that R M1 plus M2 is equal to M1 R1 vector M2 R2 vector. Now, if the coordinate system is placed at the center of mass, right? So if I place the coordinate system at the center of mass, then R is equal to 0, and that's where your book is starting its derivation from. Okay, but let's work generically first, and then we'll get to the equations that are in your textbook. Okay, so let's deal with that. Okay, so again, if R is equal to 0, this would say that M1 R1 vector is equal to negative M2 R2 vector. But looking at magnitudes of vectors, then this would be M1 R1 is going to be equal to M2 R2, and that's what's stated in your textbook. But that's a little vague, and so let's work from my equation first, and let's start from there, and let's proceed with the derivation that way. Okay, so anyway, we know that R. We're going to let this vector be equal to R. And so R is going to be equal to R1 minus R2. And the magnitude of R, the magnitude of R1 minus R2. Okay? Again, R, the center of mass, is going to be equal to M1 R1 vector, M2 R2 vector, all over the sum of the masses, and then R vector times M1 plus M2 is going to be equal to M1 R1 vector plus M2 R2 vector. Okay, beautiful. So, so what we can do here now is we can use this and this to either eliminate R1 or R2. So let's proceed to do that, right? So we can say now that R2 is going to be R1 minus R, and then we can plug this into here. Okay, so that's going to be then R, center of mass, M1 plus M2 is going to be equal to M1 R1 plus M2 R1 minus R. Okay, and then let's do the algebra. It's going to be M1 R1, M2 R1 vector minus M2 R vector. Okay, so this then is going to be equal to M1 plus M2 R1 minus M2 R vector. And then we can solve for R vector, right? So this is going to be M2 R vector. It's going to be M1 plus M2 R1 minus R M1 plus M2. And so we can divide through by M2. So then R is going to be M1 plus M2 over M2 R1 minus R M1 plus M2 over M2. And so now if the coordinate system is origin of coordinate system is at R, right, implying now that R center of mass is equal to 0, then we have R is equal to M1 plus M2 over M2 R1 vector, which is equal to M1 plus M2 plus 1 times R1 vector, and that's what's in your text. Okay, so this then is what your book calls R0, right? And then this would be 1 plus M1 over M2 times R1 in magnitude. Okay, so this is what you have in your text. Okay, it's not so clear where that came from. So so again, I just wanted to derive that for you, right? And likewise, right? Again, starting with R M1 plus M2 is equal to M1 R1 plus M2 R2. And again, R is equal to R1 minus R2. We can eliminate R1. R1 is going to be then R plus R2. And then this can be substituted into there. And so we would have then R M1 plus M2 is going to be equal to M1 R plus R2 plus M2 R2 distributing in the M1 R M1 R2 plus M2 R2. That's going to be equal to now M1 R plus M1 plus M2 R2. And then we can, again, play the same game, right? So if the center of mass is now at a coordinate origin, then we can solve for R again. Hang on here. So yeah, so this would be R then. It's going to be equal to negative M1 plus M2 over M1 R2 vector. Okay, and this negative sign is just, if you look on the diagram, is going to be in the negative direction, right, to M2. And so in magnitude then, this is going to be then R naught is, this is going to be M1, is going to be 1 plus M2 over M1 R2. And this is what's in your textbook, okay? So this takes care of the vector. This takes care of the vector portion, and this is what's in your textbook, okay? So so we're all good, okay? So now if we take a look at what the rotational inertia is, and see how far I am into this, right? So I might need to stop this module here. So so let's stop that here, and I'll pick it right up from where I left off.